Hello all, today in this video with CNN we are going to see the work of nadam optimizer and going to make a comparison with the previous optimizers we have made. I'm going to just describe the work in case of if anyone is having any doubts means you can let us know in the comment box so that we will definitely clear it out. First initially we are importing the libraries we are needed, then we are just loading the data set. Within the data set we are using the heart disease prediction data set which is downloaded from Kaggle. You can give it as heart disease prediction data set. Kaggle means you will get this data set. This data set will have nearly 14 entries. Among that the first 13 entries we will be using as the x variable, and the last entry which is the target one we will be using as the y variable. Then we are getting the info of the data set. From that you may notice that only the whole peak variable is the float type and every others are integers. Then we are describing the data set. Then we are checking whether the data set is having any null entries. If it is, you can see it is every values is showing 0. If it is not showing 0 means it is having null values, and in that case you have to work with some pre-processing functions. Then we are displaying the heat map of the data set. So this is the heat map of the heart disease data set which we are using. Then we are declaring the x variable and y variable. Within the x variable, as I said previously, since we are not using target variable, and apart from target variable we are using every variables, we are just dropping target one and using every others. In y variable we are using only the target variable. Then by use of this x and y variable and the test sizes 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like xtrain, xtest, ytrain and ytest. Then we are using the use of standard scalar function to convert into vectors with the variables like xtrain and xtest. Then we are getting the shape of xtrain and ytrain. Why? Because within the CNN input shape we have to call this train of the shape of the xtrain variable, but CNN will make use of only three-dimensional data. So we have to reshape it. Because if you notice means this is two-dimensional data, but we have to get three-dimensional data. So with the use of reshape function, we are getting a three-dimensional data, and this three-dimensional data is used as the input shape within the convolution layer. So then we are also reshaping the variables like x train and also the y train. Then we are determining the layers CNN layer contribution. So you can see CNN, it is first having the sequential layer followed by the convolution layers with kernel size, then padding, activation, filter size, input shape, etc., followed by max pooling layer, flatten layer, dense layer, dropout size and dense final dense layer. Within the dropout size we are making the drop rate as 0.5. In the last dense layer we are determining the output dimension as 1, since it is a binary classification work. In multi-class classification work, this will be replaced by the number of classes in the data set. Then this is the summary of the layer distribution. Then we are compiling by use of laws, optimizer as Adam and matrix. Then this is trained by using the fit function with the variables x train, y train, validation data making use of x test and y test, and this is run for nearly 50 approaches, and we are determining a curve. In the curve you may notice that training accuracy is higher than the validation accuracy, but for a better model validation accuracy should be higher than training accuracy. So we are just taking steps to increase this validation accuracy. Before that we are plotting the classification report and making a definition for confusion matrix, and have also plotted the confusion matrix. Then we are taking steps to improve the validation accuracy. In this step, by decreasing the dropout rate itself, the validation accuracy is increased. So previously it is the dropout rate is 0.5. Now we have decreased to 0.1. And now if you notice means the valid accuracy and validation accuracy is more or less the same, but when we notice the figure it may differ. Then we have determined the classification report and also the confusion matrix. Every other are same. So when coming to SGD optimizer, the layer descriptions, everything and all same only. The only difference you may notice is the optimizer. Previously it would be Adam, now it is SGD. We have worked for 50 approaches and we have displayed the classification report and confusion matrix. Then rmsprop, the only difference is the optimizer which we have replaced as rmsprop. Then we are working for 50 approaches. So if you want perfect a description means you can just follow a previous video. This is made in many videos. It is a continuation of many videos only. So if you want some detailed description means you can just follow this previous video. Then we are describing the classification report and also the confusion matrix. Then we are working with adadelta optimizer. Here we are just replacing every other things are same. Within the optimizer we are just replacing the adadelta. Then we are working for 50 approaches and we are displaying the classification report and also displaying the confusion matrix. And we are worked with adagrad optimizer. As same with every optimizer, we are replacing the optimizer as adagrad and it is working for nearly 50 approaches and displaying the classification report and also the confusion matrix. Then coming to adamax optimizer, the same as previous optimizers, we are replacing the optimizer as adamax and we are working for nearly 50 approaches and we have got the classification report and also the confusion matrix. And in this code we have worked with nadam optimizer. The layer descriptions and all same only. The only difference you may notice is the optimizer and it is nadam. So it is worked for nearly 50 approaches. We are got the accuracy and also the validation accuracy. Here you may notice where compared to accuracy, validation accuracy is high. And we have also displayed the classification report and also the confusion matrix. Then finally every models are compared. By comparison you may notice that now this one, that is the nadam which we have done, that too training accuracy is higher than the training accuracy of adam, you can notice. And in the end also validation accuracy of adam and nadam are more or less the same. Same wise for loss. So this is the comparison of different optimizers. In the next video we will be working with some other optimizer. Thank you.